The Rover 825 diesel engine enters the market, bringing power with economy to the executive car. This turbo diesel combines class-beating performance with refinement and style. This program will introduce you to the new 825 diesel engine and give you an insight into its features. A booklet accompanies the video, which is packed with useful information and a quiz. First, let's see how the Rover 825 diesel engine fits together. The cylinder block is cast iron for maximum strength, and the crankshaft is housed in a special tunnel machined directly into the block. A one-piece alloy bearing carrier houses the rear main bearing, and there are 3 more two-piece carriers inside. Like the K-series engine, the 825 diesel uses wet cylinder liners, where coolant is circulated around each liner for maximum cooling effect. The pistons have specially coated crowns to help them withstand the immense pressures and temperatures. The oil pump, brake servo exhauster and camshaft are all gear-driven from the crankshaft. Selective head gaskets are used to seal the separate cylinder heads. The valves are operated through push rods and rockers with conventional valve clearance adjusters. A steel adapter plate provides a mounting point for the new 5-speed gearbox. The pickup strainer draws oil from a laminated sump. The flywheel, clutch plate and diaphragm sprung cover plate are all quite conventional. A 2-piece cast iron exhaust manifold houses the turbocharger and is sealed to the cylinder heads with separate gaskets. The alloy intake manifold also uses separate gaskets. A special manifold, which also houses the cooling system thermostat, carries the return flow of coolant from the cylinder heads. A mechanical injector pump, which develops around 8,000 pounds per square inch of fuel pressure, is gear-driven from the camshaft. This pump delivers the correct amount of fuel with split-second accuracy to 4 mechanical injectors. The alloy rocker cover is sealed to each cylinder head with a single-piece gasket. The timing cover has a similar laminated construction to the sump and should be treated with care. All the necessary ancillaries, power steering pump, compressor for the optional air conditioning and alternator are belt-driven from the crank pulley through an automatically adjusted multi-V belt. So what happens inside one of the cylinders? Diesel engines don't need spark plugs because of their extremely high compression. On the compression stroke, the air is forced into such a confined space that it heats up to around 900 degrees centigrade. When fuel is injected into the pre-chamber, it ignites spontaneously. The combustion then spills out into the main combustion chamber to force the piston down on the power stroke. A small electric glow plug warms the pre-chamber to help cold starting and remains on for a short period afterwards to cut down emissions of white smoke from the exhaust. A cutaway head shows the glow plug, injector and pre-combustion chamber. So that's a brief look at the operation of the VM diesel engine. If diesel engines are new to you and you'd like to know more, look out the Diesel Introduction video program. Now let's take a look at the engine checks you'll have to carry out when an 825 turbo diesel comes in for a service. The first check is the gearbox oil level. Having removed the level plug and let the oil drain out, replace the plug and add half a litre of oil through the reverse lamp switch hole. After checking the gearbox oil, the engine oil will need replacing. Remove the rocker cover. Loosen the head bolts off and tighten the bolts to the correct torque. While you have the rocker cover off, check the valve clearances. Now, the fuel system. To drain any water from the fuel filter, open the bleed nipple until the water has drained out and fuel starts to flow. Now check the tension of both the auxiliary and the water pump belts. At the 12,000-mile service, the auxiliary belt will have to be retensioned. This is done by turning the bracket behind the pulley through 90 degrees. The service maintenance check sheet outlines all the jobs you need to carry out at each service. Now let's take a more detailed look at the new VM diesel engine. But before you attempt any work on this engine, you must contact Network Service for authority. First on the list of special features are the cylinder liners. They're made from cast iron for high resistance to heat, wear and pressure. The liners are free to expand in any direction without the risk of distorting. Before you fit a liner, place it in the block minus its shim and O-rings. Now use a DTI to measure the difference in height between the top of the liner and the block. This will give you the size of shim that's needed. Each liner has 4 O-rings, 2 brown, 2 black. The coolant is sealed by the top brown and the 2 black O-rings. The brown O-ring at the bottom seals against crankcase oil. Fit the shim and O-rings. Then apply Loctite to the liner and lubricate the location point in the block. Next, put Loctite on the liner seat in the block. Clamp the liners down and check the fitted height by using the DTI. If you fit a cylinder liner, you must wait 6 hours before you start the engine. This allows the Loctite time to set. The cylinder block has an unusual tunnel-shaped layout. This type of layout and the use of partitioning walls makes the block extremely rigid. The first items to fit are the cam followers. Lubricate the followers before you slide them into position. Now loosely fit the camshaft. The crankshaft can now be fitted. There are 4 aluminium bearing carriers on the crankshaft. Each one has its own oil jet, which must face the front of the engine when fitted. The jets are supplied oil by external pipes that enter through the side of the block and into the carriers. The hole in the carrier must be in line with the centre of the crankshaft web, or you won't be able to fit the pipes. The rear main bearing is also housed in an aluminium carrier with an oil jet that must be pointed towards the front of the engine. We can now fit the vacuum pump and tighten up the camshaft bolts. Dots are stamped on the gears to enable you to time the engine. A single dot on one gear should line up with the double dots on the next. The pump gear is split in half, with the rear half offset by about half a tooth. The two halves are spring-loaded and twist against each other. This helps get over the problem of free play between gears and cuts down on noise. With the camshaft and crankshaft both fitted, turn the engine to fit the pistons. The pistons have 3 rings. The top 2 are compression rings, while the lower one is a 2-piece oil control ring. When you refit the pistons, the rings must be staggered. The numbers on the conrod caps must be on the same side as the number stamped on the conrod. Apply Mollyguard to the threads of the conrod cap bolts when fitting a piston assembly. The oil pickup strainer and sump complete the bottom end of the engine. Probably the most interesting part of this engine are the cylinder heads. Each cylinder has its own separate aluminium head. Before you fit the valves to the head, check them for wear and damage. The valves are fitted to the head in the same way you would a normal engine. The only difference here is the springs are much stronger to cope with the high forces created by the engine. Measure the valve head stand down using a straight edge and feeler gauges. If the stand down is outside the limits, a new valve will have to be fitted. Head gaskets come in 3 sizes. To select the correct gasket, fit a DTI across number 1 cylinder. Rotate the crank until the piston is at top dead centre. Now measure the difference in height between the piston and the top of the block. Do this for each cylinder and fit the biggest size of gasket you require to all 4 cylinders. This ensures the cylinder heads will be level and allows you to fit the manifolds without any trouble. Lubricate all the head bolts with a moly disulfide grease and fit them loosely. New bolts must be used every time you fit the cylinder heads. Loosely fit the inlet and exhaust manifolds. This will line up the cylinder heads. Each inlet and exhaust port has a separate gasket. Now to start tightening the head bolts. Tighten the inner bolts in sequence to 30 Newton meters. Then, using a degree disc and pointer, turn them through 60 degrees, followed by a further 60 degrees. The bolt tightening sequence is shown in the video booklet. Now, torque the outer head bolts on the exhaust manifold side up to 80 Newton meters. Then torque the bolts on the other side to the same figure. You can now torque the manifold bolts. The final setting of the head bolts must be done when the engine is fully rebuilt. Slide the push rods into the engine and fit the rocker arm assembly. The push rods should be fitted with the rounded end in contact with the cam followers. Don't forget to fit the steel springs as they retain the rocker arms on their shafts. The cylinder heads are supplied oil by an external oil pipe. The oil flows through the head and out through the centre of the rocker shafts to lubricate the arms. The glow plugs are supplied an electrical feed by the terminal links. Make sure the links don't touch the block when they've been fitted, as this would cause a short to earth. Every time you fit an injector, you must use a new copper washer. Be careful not to damage the injector pintle. Damage it and you'll increase fuel consumption, noise and the amount of smoke leaving the exhaust. Now to fit the injection pump. The pump increases the pressure of the fuel to over 8,000 psi, then directs it to the correct injector. Fit the pump to the engine and loosely tighten the bolts. Now fit the timing gear. Remember to align the timing marks on the gears. Fit the timing cover. A useful tip here is to fit it with the injection pump gear removal tool in place. After fitting the bottom pulley, remove the flywheel locking tool. Now to set the pump timing. Slacken the screw securing the cold start cable and release the tension. This cable advances the timing of the engine when it's cold. Start at top dead center number 1 cylinder. Remove the high-pressure pipes. Remove the center plug from the rear of the pump and fit a DTI. Rotate the crankshaft anti-clockwise until the needle on the DTI stops moving and zero the gauge. Now turn the crankshaft clockwise until the white mark lines up with the top dead center pointer. You can now adjust the position of the pump until the DTI gives a reading of 0.68 millimeters. Always make the final movement of the pump towards the engine. Tighten the bolts to the correct torque and check the pump timing again. The high-pressure pipes that supply the injectors with fuel can also be fitted. Use 2 spanners when you tighten the bushes so you won't damage them. The fuel lift pump is fitted on the side of the block and is driven by the camshaft. The coolant manifold runs across the top of the engine. Hot coolant rises up through the block into the manifold. A thermostat is located in the housing. Despite having separate heads, there is a one-piece rocker cover and gasket. The gasket can be reused. Now refit the rest of the hoses. The water pump is bolted onto the side of the block and is driven by a V-belt. The alternator and automatic tensioner for the auxiliary drive belt can then be fitted. A gearbox adapter plate sits snugly on the rear of the block. The flywheel can now be attached. Use the special tool to align the clutch plate as the cover is fitted. An adapter plate seats the starter motor up to the flywheel. The performance of the engine is increased by the use of a turbocharger positioned between the exhaust manifold and the exhaust downpipe. Any grit or dirt allowed to enter the turbo can cause serious damage. When fitted in the car, a shield protects nearby components from the intense heat generated. With the gearbox attached, the unit is ready to be fitted to the car. Due to the size of the unit, you'll have to tilt the gearbox end of the engine down to get it into the engine bay.
Go up a bit. Okay.
After tightening the engine mountings, fit the power steering pump and auxiliary drive belt. To fit the belt, loosen the bolt on the rear of the tensioner pulley. Move the pulley upwards and use the special tool to hold it in position. Then set the belt tension. It's done automatically. When the belt is fitted, you'll need to turn the adjuster pulley through 90 degrees. Full details are given in the booklet. Connect all the ancillary pipes and electrical connections in the same way you would a normal engine. Now you can add the engine oil, gearbox oil and coolant. Before you start the car, you'll need to bleed the low-pressure fuel system. Slacken the nipple on the fuel filter and pump fuel through using the lever on the fuel lift pump until it appears bubble-free from the nipple. Then retighten the nipple. To make sure air is not trapped in the injector side, start the engine and bleed each injector in turn. Don't forget the final tightening sequence on the head bolts after the engine has been warmed. First, tighten the 10 inner bolts in sequence through 30 degrees. Now torque the outer bolts on the manifold side to 90 Newton meters. Finally, torque the outer bolts on the injection pump side to the same figure. When the engine has cooled, check the coolant level. If below the indicator plate, top it up. Now to set the idle speed. First, stick a piece of tape on the crank pulley. This will enable the optical tachometer to measure engine speed. Disconnect the cold start advance cable. Now loosen the idle speed lock nut and adjust the idle speed screw until the engine idles at between 775 and 925 revs per minute. Setting the high idle speed is just as easy. Again, the engine must be warm. Place a 4.5mm spacer between the cold start advance lever and its stop. Now get someone to sit in the car and run the engine between 1,000 and 1,100 revs per minute. When the engine is running at the correct speed, loosen the throttle lever stop and slide it up to the accelerator lever. Now tighten the nut and remove the spacer. Now let's have a quick recap on the engine's main features. Top-hung wet liners are sealed with 4 O-rings. The block has a tunnel-shaped layout for extra strength. The crankshaft bearings are held in aluminium carriers. Put the carriers in a freezer for a couple of hours before you refit them. Also, make sure you fit them the correct way. A gear train directs the drive from the crankshaft to the camshaft and injection pump. Dots on the gears allow you to set the engine. Each cylinder has a separate aluminium head. They must not be removed individually. Remove one, remove them all. The fuel is injected into a small pre-combustion chamber in the head, and each pre-combustion chamber has a glow plug to aid cold starting. The overhead valves are operated by push rods and rockers. An injection pump increases the pressure of the fuel and directs it to the correct injector. The performance of the engine is increased by the use of a turbocharger. Fitted with this new engine, the Rover 825 diesel returns class-beating performance. The addition of a diesel engine to the Rover 800 range completes a winning team and adds a true combination of grace, economy and power. The Rover 825 diesel engine.